Hey guys, it's Miss Delcambre. So today is the 27th of January. It's a Wednesday. And here's a rundown of our day. So you'll need your journal, glue, pencil, and a highlighter. You need your notes on 12.2, which is addition and subtraction of equations. There are two pages to it. There are two pages to it. So let's get going. All right, let me pull up our notes. Okay, and there are two notes, one here and then one that has a right angle and it has a lot of space down here. So let's get those two out. You can find them in the notes section. Maximize this and zoom in. So using subtraction to solve equations. So today is 1/27/2021. Grab my highlighter. So using subtraction to solve equations. So using subtraction, solving equations. You need to get a new highlighter here. Mine's running low. So removing the same number of tiles from each side of the equation, Matt, model subtraction, the same number from both sides of an equation. So think about this as a scale, guys. All right, it's like a pan balance scale. What you remove from one side, you need to remove from the other to make it balance. Okay, so with equations, the subtraction property of equality means you can subtract. You have to do the same number. That's key. The same number from both sides of an equation, and the two sides will remain equal. Okay, so the key thing is when you subtract on one side of an equation, you must subtract on the other, and it will remain equal. So when an equation contains an addition, solve by subtracting the same number from both sides. So here is an equation, and we know it's an equation because it has an equal sign. So it says 5 equals W plus 1.5. Okay, I'm that weird person who likes to have my variable on the left side and my number on the right side. So I'm rewriting this. So W plus 1.5 equals 5. You do not have to rewrite it. I just write it because this is what I've been used to. Okay, this is the way I learned it. I like my variable on the left and my number on the right. Okay, so I need to get the variable by itself. Okay, so I need to figure out what this is. Well, I need to remove this plus 1.5. So how do I remove an addition? Well, I use subtraction. So I'm going to subtract 1.5. And if I did this to one side of a scale, it's going to go up and this is going to go down. So it's not going to be equal. So I must subtract 1.5 on this side of the equation. Okay? So when I solve this, this cancels out, leaving me with only the variable W on this side is equal to, and then I need to subtract here. So that's 5. I could think of it. I put decimal and 0 behind it. So I've got to borrow from this 5, make it a 4, make that a 10. 10 minus 5 gives me 5. Bring down my decimal. And 4 minus 1 gives me 3. So W is equal to 3.5. All right, now I'm going to place that number. It says graph the solution on the number line. Okay, solution. Graph the answer. So where would it be? Okay, so it's 3.5. It's a positive, so it's going to be to the right of 0. And it's going to be between 3 and 4. So that's where my dot goes, and that's it. You don't have to do anything to that. You just have to put the dot there to show that that's where the number would be on the number line. Okay. Now, using addition to solve equations. So using addition to solve equations here. When an equation contains subtraction, solving by adding the same number to both sides. Okay, think of it like a scale. You have a scale, it's balanced. I add some to one side. What happens? That side goes down, the other side goes up, so it's not balanced. So I have to add the same amount to the other side to keep it in balance. So the key thing here is the addition property of equality. You can add the same number. Key thing, guys, same number to both sides. You can't just do to one. You have to do it to both sides of an equation, and the two sides will remain equal. Okay, So here's our equation. We have h minus a half is equal to 3/4. Well, I'm just going to rewrite it here so I have some room to show my work. H minus 1/2 is equal to 3/4. Okay? So I need to get rid of this half, and it's being minus. So I need to do the opposite. So I need to add a half on this side, and I need to add a half on this side. Okay? So then I'm left with h on this side, and I kind of ran out of room here. And then I need to add 3/4 plus a half. So I can think of this two different ways. I'm going to think of this as like money. So 3/4 is like 75 cents, and a half, well, that's like 50 cents. So 75 cents plus 50 cents, well, 75 plus 25 gives me $1, and then I have a 25 cents left over, so it would be 1.25. Or I can change this 1/2 into 2/4 because it's the same, and I can add 3/4 and 2/4 together, and I get 5/4, which is 1 1/4. So my h is 1 1/4, or 1 2500ths. Both of them are the same. So when I graph this, I'm going to look at 1. This would be a half, and it's in the middle between 1 1/2 and 1 1/2. So that's where my dot's going to go. That's where my dot's going to go, and that's graphing the solution. Okay. Okay, let's go to our next page. All right, solving equations that represent geometric concepts. So you can write equations to represent geometric relationships. Okay, recall that a straight line has an angle measure of 180 degrees. So remember that straight line is 180 degrees. Two angles whose measure have the sum of 180 degrees are supplementary. So supplementary add up to 180 degrees. Okay? Two angles whose measures have a sum of 90 degrees. So two angles that measure 90 degrees are called complementary angles. And there's a little way I remember this. Okay, so C comes before C comes before S in the alphabet. So I'm going to write complementary. Okay, so 90 comes before 180 on my number line. So complementary. My next one I'm going to just write is supplementary. supplementary. And that comes after C in the alphabet, and 180 degrees comes after 90, or 180 comes after 190 on a number line. If you think of it, also, supplementary has more letters in it than complementary, so supplementary will always be more. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And supplementary is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Maybe my counting's off. I always thought 1. Well, maybe they're the same letter. I always thought supplementary was a lot bigger, I guess because I must have added another P. But they are the same amount of letters. So disregard that whole message. All right. So let's look. Write and solve an equation to find the measure of an unknown angle. All right. So we have this angle over here. All right. But we have a box, and we know that boxes, if it's here, it's always going to be 90 degrees. So this is always going to equal 90 degrees because it has a box in it. Okay. We know that we have 65 degrees. So 65 degrees plus x is equal to 90. So we've written our equation. Now we need to solve it. So I need to get rid of the 65. So think of it like if I cut off that 65. If I cut off the 65 here, I must cut it off, take it away from this side. Then I'm left with x is equal to, now I need to do some subtraction. So I have 5, that becomes an 8. So I have 25 degrees. And I can check this by saying 25 plus 65. Does that give me 90? Okay. And 25 plus 65, that does give me 90. And 90 is equal to 90. So it checks. Some degree symbols there. Okay. Number 7. So write and solve an equation to find the measure of a complement of an angle that measures 42 degrees. Okay, so complement. Even though I do not have a drawing here, I'm going to draw an angle that's 90 degrees. Now, it probably is not exactly 90 degrees, but I know I'm going to put a box in it to tell someone that that means it's 90 degrees. Okay, and I'm going to draw a line right here. And I'm going to say that this is 42 degrees. Is it accurate? No, but I'm showing that right here, this angle is supposed to be 42 degrees. And I need to figure out what this is. So when I'm writing this out, I have x plus 42 degrees equals 90 degrees. Okay, to solve this, I'm going to subtract 42 from both sides. And when I subtract, x is going to equal 48 degrees. Okay, and I can put this in and check it as 48 plus 42. Does that give me 90? Well, 48 plus 42 does give me 90, and 90 is equal to 90, so it is check that that one will work. All right. 2 things I want you to remember. Now think back to 4th grade when you started doing angle measurements, that you have a straight line, and that's 180 degrees. So measurement of from here to here is 180 degrees. And when you have a right angle, always has a box in it, and it's always 90 degrees. Now, when we're solving equations that involve addition and subtraction, you are using inverse operations. And I want you to remember the rule. With inverse operation, you have an addition. The inverse of that is subtraction. When you have subtraction, the inverse of that is addition. So you always want to use the inverse operation to solve your equations. Okay? So the next thing I'm going to show you is our equation mat. Okay, really nothing fancy, and you can make one at home. I'm going to zoom out for a second. And you will be seeing these type of mats when you get to middle school as well. So we're kind of introducing them now so you can get used to them, and it won't be a shock when you get to middle school. Okay, so in the box here, we're going to put an equal sign. Okay, we're going to do 2 examples. So I have m plus 12 is equal to 30. Okay, with my mat, I have my variable on one side and what equals to another side. And I need to figure out what m by itself is going to equal. So I have plus 12. Well, I need to get rid of that plus 12. With inverse operation means that I need to take that 12 away. So I need to subtract 12 on this side. And think of it like a scale. If I take 12 away on one side, I've got to do it to the other side in order for it to be balanced. It's very, very important for you to show that you did your work on both sides of the equation. I cannot stress that enough. Both sides of the equation. Get in the habit of doing it now so that when you get on to middle school and in high school, and when you're doing this, you won't struggle. All right, so I'm left with m on this side is equal to 30 minus 12 gives me 18. Okay, and then I can check that. So 18 plus 12, does that equal 30? Well, 8 and 2 gives me 10, carry a 1, 1, 2, 3, 30 is equal to 30. It checks. Okay? So get in the habit of showing your work underneath it. Like order of operations, when we do our work and we put it underneath it, and we continue on, exactly the same. You want to show your work underneath it. Okay, it's very important so that your teacher knows that you understand what is going on. Let me erase my board now. All right, my next one I'm going to do, P minus 86 is equal to 120. Okay, I want to get P by itself, so I need to get rid of this minus 86. And I do that to get rid of a subtracting problem. I need to add, and I need to add the exact same amount. So I need to add 86. And if I do to one, I must do to the other. So I'm adding 86 over here. Okay, this cancels out, leaving me with P is equal to, okay, 0 plus 6 is 6. 8 plus 2 is 10. Drop a 0, carry a 1. 1 plus 1 is 2. Gives me 206. Okay, then I can check the work. 206 minus 86. Does that give me 120? Yes, it does. 120 is equal to 120. Okay. All right, so that does it for me today. This is also for the lesson for tomorrow as well, because we will be doing more practice on adding and subtracting equations. So that does it for me. Have a wonderful day, and I will see you on Friday. Bye.